Hi subscribers and watchers, what's up? This is Vivs from SlideNerd here. In this video, I'm going to talk about static methods in Java. In the previous video, I was talking about static variables out there, and if you guys haven't seen that, please check the links in the description text below or check the playlist Object Oriented Java on my channel. So first let's talk about static methods and try to understand why do we need them. So here we have a class person. Now as you know, a person can have attributes like name, address. You can have a method like getName that returns the name of the person. You can have calculateAge where it takes an integer argument representing the date of birth. Now of course it should be a string over here, or you can probably take a date class over here. It's completely your call. For purpose of understanding in this video, what I'm simply doing is calculating the age from the given date of birth. Now let me tell you exactly the process of calculating the age. But here if you take a look at the object over here, for say P1, an object of class person, it will probably have the name, the address as something. The getName method will return this name over here. The getAddress method, if it exists, will return the address here. And there's the calculateAge method. Now notice carefully, for finding the age, you're gonna find the current time, you're gonna take the date of birth, and you're gonna subtract both of them and get the difference in terms of days, and then probably convert that into years or months. Right now that's how calculating the age works. Here if you take a different object, take a look carefully. String name for this person will be different. For example, the first person's name can be Alan, the second person's name can be Bob, right? Same way the address will differ. The getName method will return this name for this person, right? But calculateAge is going to perform the same operation again. It's going to take the date of birth from somewhere, it's going to find the difference in respect to the current time, and so on. So in other words, if you notice something, the calculateAge method here does not depend on the name because it is independent of that. It does not require the address. It does not require the help of this method getName. All it says is that give me a date of birth and I will find the difference with respect to the current day, right? In this scenario, what we can do is, instead of every object working with this separate method calculateAge, we keep this method common across all the objects out there, and this is what a static method is. So in other words, now we are saying that this calculateAge method belongs to the class person. In other words, any object, anyone can call this method out here, simply pass the date of birth and they can get the value. Now remember, the age or the value calculated here is not specific to P1 or specific to P2. It is just some value that is getting returned. So now let's take a deeper look at static and try to understand what we can do with this. Let's take a look at the picture behind static. So here there's a class test and I have my normal variable called int normal. Then there's my static variable, which is static int static var. Then there's of course my normal method and my static method. So if you remember, as per our earlier discussion, the normal variable and the normal method are going to be different for every object, but the static variable and static method are going to be the same across all the objects out there. In other words, the static variable is a common piece of data that's going to be used by all the objects, and the static method is a common set of operation, or you can say function, that is going to be accessed by all the objects out there. So if you go to the main method, to use the normal variable or normal method, you have to first create the object of class test. In other words, you say test t1 is new test. Then you can probably say t1.normal method. Again, if you create t2, another object of class test, simply say t2.normal method, and that takes care of calling the normal variable and normal method. In this case, normal method is going to perform some operation that is related to the data of t1, and when I say data, I mean this normal variable here. Now if you take a look at the static method, it is simply said class name dot method name. In other words, this method is going to do something which does not depend on the data for this class test. In other words, it does not depend on int normal, it does not depend on normal method, it's going to be something else, and that's what the static method is all about. So if you take a look at this in the form of an image, we can clearly understand what is going on. This yellow box over here represents the world where everything is controlled by objects. For example, there is t1 object over here that is actually pointing to the class, and there's t2 that's pointing to an object of type test. there's a normal method, normal variable, normal method, normal variable, right? Now normal variable for T1 is different from the normal variable of T2. Normal method of T1 will perform some work on this normal variable that belongs to object T1. Normal method of T2 will perform some work that relates to this normal variable that belongs to T2, right? And that is what methods are all about. Now if you take a look at the other area, this is the place, the gray box is the place where there are no objects. There are just plain variables and plain methods. Anyone can access these methods and variables subject to certain conditions. So now let's take a look at those conditions in a little more detail. So here again the yellow box is the world of objects, and the other box that we have is the world of static variables and static methods where there are no objects. So try to imagine this. At the top side, an object controls everything. At the bottom side, you don't need an object, right? So from a normal method which works only with objects, you can call a static variable or a static method that does not require any objects. No problem with that. But the other way around is gonna cause problems, because at the top side you require objects under all circumstances, but in the bottom side here in the gray box you don't require objects, right? If a static method says it wants to access the normal method or the normal variable, it is going to require the object T1 under which the normal variable and normal method act, right? In other words, from a static method to access a non-static method, you require objects out here that control the method or the variable. So these are two basic rules that we need to talk about. Hence direct access is not possible. In other words, if you go to the static method and you simply say normal method, error, it's not going to work. You have to say T1, or in other words create an object of test first and then call the normal method on that particular object. So now let's take a look at the rules that we just discussed. A static method can be called without using any object. In other words, it directly exists. There's a class name dot method name, and that's how you call static methods. Now you can create a collection, or you can say a group of static methods inside a class, like your math class, which has many static methods inside, like POW and other SQRT and other methods over there. So a non-static method, which is your normal method, can reference a static variable or static method directly. Now this is something which we just discussed, but if you take a static method, it can call a static variable, no problem. But if you want to access a normal variable or a normal method, you require the object that controls that normal variable or normal method. A static method, of course, can call other static methods. There is no problem with that, again, because both of them belong to the universe where there are no objects. So you cannot use the this keyword or super keyword inside static methods, because this keyword in general refers to the object which called the method, right? But since static methods are not called by objects, you cannot have this keyword. Now we will be talking about this super keyword in the upcoming videos when we talk about inheritance. But if you guys haven't seen the video on this keyword, please check our playlist, which is Object Oriented Java, on my channel. So in this video, we talked about static methods and try to understand how they interact with other static variables, methods, and non-static variables and methods. In the next video, we're going to talk about something very important. Why is the main method static, and what other uses you can have for the static keyword. In the meantime, if you guys do like what you saw, please like this video, subscribe to our channel, let us know your thoughts in the comment boxes below. Thanks for watching. We'll catch you guys in the next video. Have a nice day.